Hello everyone. I hope so everyone is good. So just let me have a look. Okay. So yeah, we are all good. Okay. So welcome to this session where we will be talking about machine learning, introduction to machine learning. And I'm just wondering, how many of you are aware of machine learning or has any kind of experience with machine learning? Please raise your hand if there is some kind of an experience, you know, in any form or shape, so that I'm aware of who's where, what should I cover, what should I not cover. Okay, thanks. Okay, there are two people who have, okay. So anyone who is having any experience with Python or coming from such kind of background, okay. Anyone who's having any programming experience, not specifically Python, or coming from like software engineering kind of uh, you know, background. Okay. Lastly, anyone who's coming from data analysis kind of background, like who's working with like Excel and so on, like spreadsheets and that kind of a thing. No, right? Okay, interesting. So okay. Um, what I'm gonna do over here is to explain a little bit the whole process of what machine learning is. Okay, I'll introduce the whole pipeline, like how machine learning works. Okay. And then I'll give you an example of how easy it is to actually do the machine learning. Although there is a bit of mathematics and so on, but I'll explain in few lines of code how you can even implement one of the most complicated algorithms. And Python has made this really easy, particularly with different kind of algorithms. The libraries, algorithmic, like the libraries which has implemented those complicated algorithms in single lines of code. We will be using them, right? So let me first of all share with you the whiteboard where I will kind of explain to you what the whole process look like. Okay. So let me just move this up. Can you see my screen? Can you see the whiteboard? Thanks. So, yeah. So usually what happens with the machine learning process is that you have some kind of data, right? What do we mean by data? Well, the data can be of any form. For example, it can be image, right? It can be language. That's the interesting part, right? It can be speech, right? Or maybe it can be, any kind of spreadsheet like data you have seen with the Excel files, like table or something like that, right? So the data can be of any form, right? These are some of the forms. Even the data can be in the form of a graph, right? Now, again, you might think, where would we use that? Well, graph data is used for social media analysis and so on. Nevertheless, these are some forms of the data that we will be using, right? Um, and with these different kind of data sets, we have different kind of tasks that we are interested in, depending on, where are you coming from and what kind of industry you're working in, right? I can give you example from any of the industry that you're working in as how you can make use of machine learning. I can assure you that it can be used in any of the industry that you're already working in or you're studying in, right? Whether it can be, agriculture, medical, whatever. I mean, you just name it, mining, transportation, um, a- any healthcare facility, you name it. Like every single industry can use machine learning because every single industry generates a lot of data. And we make use of those data sets to bring intelligent decisions, right? Well, how do we do that? The way the way we do it using machine learning is in different manner. The simplest explanation would be to divide the whole machine learning process into two different processes, right? The one is what we would call a supervised machine learning models, right? I'll call it supervised ML processes. The another one is what we call unsupervised machine learning model, right? Although there is more to it, but I'm just simplifying this whole thing into these two sections, okay? And I'll also be kind of focusing myself today only on supervised machine learning because it is relatively simple to explain and so on. But the difference between both the supervised and unsupervised machine learning is that when we have data, right? For example, let's pick the image data, right? So let's say we have the image of a cat, right? And we also know that this is an image of a cat. So we have the input, right, which is an image, but we also have the output. The output is the actual label, the actual information about that image that we know of. That, okay, this image is an image of a cat, this another image is an image of a dog, right? And so on, right? So we have this information about the image, about the input image, right? So if we have this input output pairs, okay, the way we learn the relationship is what we call supervised machine learning because we use the output labels to supervise the learning process. It's the same thing as we do in schools, right? So, for example, what do we do with the students? We start with telling the students that, oh, okay, this shape, for example, this shape is what? This shape is a shape of letter A, right? Now, if a student makes a mistake and calls it B, we again tells them that, oh, it's not B, instead it's A, right? So we kind of reinforce this a process by correcting them, by supervising them, right? So this is why we call this kind of a method as supervised machine learning methods, because we have a output label which kind of supervises the learning process. Now, what is the learning process? I'm going to explain it. But the main idea is that there is some kind of supervision happening on in this machine learning process. Okay. And for supervision to happen, we need to have what? We need to have the output labels. Make sense? Okay. Now, in the unsupervised machine learning, we don't have the labels. Imagine you have images, right? And you don't know what these images are of, right? Um, you have no information in clear manner, right? So, for example, you can go on and download million of different images from internet, but there is no information available with you that, okay, these million images, what are the labels related to these million images, right? So if you ask me to do some machine learning on those images, because there is no label, there is no way to supervise my learning process, right? I will just use those images in unsupervised manner to learn some kind of a pattern. Now that pattern can be, for example, one of the tasks could be, let's say, group similar images, right? Now that's interesting task. Although I don't know the labels of images, but looking at the pattern, the structure in images, I can group similar images, right? Because the images of dog, although they will be different from each other, but there will be some pattern in it. So getting that pattern without labels is what we call learning in unsupervised manner, right? One of the another kind of an example not related to images in this category would be marketing in the marketing analytics would be to just segment out the customers. So let's say you have customers data, right? Which means that you have a tabular data for each customer. You know that this customer came in on this day, bought this stuff, and this is the age of the customer, blah, blah, blah. All of the details of the customers, right? And now what you need is you want to know to you want to group different customers, right? The uh, um, high spending customers, right? And let's say the low spending customers, right? Now, let's say you don't have any labels. So, of course, it's an unsupervised learning problem, right? So, what you would do is you would just apply some kind of unsupervised machine learning model. And then what you would do is basically, come up with two categories. And that first category customers, let's say you have total of million customers, right? And half of them are like high spending customers, or maybe 60% of them are high spending customers. You just separate them out in a way, right? Using some unsupervised learning manner, right? And the way you would do is because you don't know who is high spending and who is low spending, you just categorize the similar kind of customers together. And from there, you know that, oh, okay, all the high spending customers are from the age, let's say 20 to 35, right? And all of the low spending customers are, let's say, boys, for example, right? So from there on, you can, do some kind of analytics as well. But before you get to the analytics part, the whole process of doing the segmentation is what comes under this category, right? There are so many other kind of tasks that I can talk about, but the main point is that you have these machine learning methods like supervised machine learning, unsupervised machine learning, right? Which works like a black box methods. Why I'm calling it a black box for now? Because this is kind of an introduction. This is not a detail. It's just that it's something which does kind of a magic to give you something interesting, something useful. Now, what is inside the black box? For now, you don't have to know about it. Okay. Although I'll explain a little bit about that. And at the end, I'll show you how Python makes you even more comfortable with using these black box models without even knowing a lot of details about it, right? But yeah, so let's have a look at that. So as I said, you have a data. That data can have the input, okay, or also the output, right? Now, there is some kind of a black box model, right? Whatever that model is, I'm just going to call it machine learning model, okay? There is a machine learning model, and this input would go inside this machine learning model. If there is output associated, right? This output would also go inside this machine learning model, right? Let's say we are talking about supervised machine learning, so we have output associated with it, right? This machine learning model is going to do the predictions, right? So what is going to happen is it will give us the prediction, right? Now, the prediction is what machine learning model will kind of, learn, right? It's something that we want to improve, right? Because from the input, let's say you have these samples, for example, you have, let's say I'm just going to give you two examples of the tabular data. Let's say you have age, you have degree, right? And then you have income, for example. So the age is, let's say, 15, degree is nothing, and income is only, let's say, 500, right? And then 25, yes, and let's say 5,000, and so on, right? So let's say all of this goes on, right? So these two are the the input, right? And this one is the output, right? So this is a tabular data example, right? So now you want to predict, right? Let's say you want to create a model which would map this input to output, right? So you want to predict for the new sample, if somebody is having an age of 26 and there is no degree, then what would happen, right? That's the question that you want to predict for the test data, right? So to do that, what you need to do is, first of all, find this function mapping between the input and output, right? So to do this function mapping, you will use this machine learning model, right? So you have input, you have output. So the input in the first case, the first sample, is that you have age 15 and there is no degree, right? So this is the input. And the output in the first case is 500, right? Okay. Let's say the 15 and no goes into the machine learning model, and you do the prediction to be, let's say, 1,000. Now, prediction is incorrect, right? The prediction is 1,000 and the true value is 500. So there is some kind of an error that your machine learning model is making, right? That's the whole process of machine learning, right? So you don't know how machine learning is coming up with this prediction, whatever that is, right? But there is some error, right? And that error is 1,000 minus 500, right? Which is equal to 500, right? So this is an error, right? And you want to correct this error. So what you would do is you would correct this error by going back and doing something with this machine learning model, right? Now that something is, again, you don't have to worry about it too much, right? But there is something that you need to do with it. There is some mathematics involved with it, right? So once you do that something, this machine learning model would next time make a prediction of, let's say, 800. You still are making some error, right? That error is this time 300, right? You would again go back and correct this machine learning model, in a little bit manner, right? In a small manner, right? In a small chunks, right? This would improve its result and would make it 600 and so on. Eventually, it would try to get as close to the output as possible. Let's say 510. And you feel like, okay, this is an acceptable result. Although we cannot predict perfectly, this is acceptable result. So this machine learning model has been trained. This is what we mean by training a machine learning model. We have trained the machine learning model, right? Does that make sense? Any questions around that until this point of what machine learning is, what supervised and unsupervised methods are, and how we actually train the supervised machine learning model in this manner? Any questions around that? No?
Actually, hi, this is me. I'm just curious, like what scenario, or if you can provide an example when what in situation that we would use the unsupervised versus supervised.
Okay. So one of the famous example would be, let's say, again, I did not give example of language, so I think it's a good place to actually give you the example of language. It's a good question, because language is being used a lot, right? So, for example, if I ask you to give me, to given a sentence, predict the sentiment, right? Sentiment contained in that sentence. It can be positive, it can be negative, it can be neutral, whatever, right? So these are three different classes of sentiments that I have. And I want to tell me what is the sentiment in this sentence, right? Okay, how would you do that? Of course, you're going to use some kind of a machine learning model. Okay, now what machine learning model, supervised or unsupervised? That depends on what kind of input data I have to train my machine learning model, right? So if the input data that I have contains, let's say, 100,000 sentences and their sentiments associated with it, then I can use supervised machine learning model, right? I can use the supervised machine learning model to do some kind of function mapping between how sentence maps to a particular sentiment, right? And then use that machine learning model to predict the sentiment of a sentence, right? If I have this kind of data set, I can use supervised machine learning model because I have sentiments associated with each sentence to guide the learning process of a machine learning model, right? Let's say I don't have this data. Instead, I have only 100,000 sentences, right? I don't have anything else, right? Well, in that case, predicting sentiments is a difficult task, right? That is what I would call unsupervised learning method, where I would be using unsupervised, because I don't have associated sentiments, associated labels, right? That is where I would be using unsupervised method to predict the sentiment. Okay. Now there are different unsupervised methods as how we do it and so on. But I hope so that makes sense as because we don't have the label, we do this task, right? One of the another kind of a famous task would be topic modeling, right? So you have different articles, right? You have different articles written. You really don't know what articles map to. Let's say you have you want to categorize each article into one of the five categories, right? Either it is about crime, right? Or maybe it is about movies. That article is about whatever. You can name any other five categories, right? So let's say you want to categorize each article into one of those five categories. Well, it is very painful and very expensive to get the labels for any kind of data. Okay. good label data set is extremely costly process. Okay. There is actually a service in Amazon called Amazon Mechanical Turk, okay, which hires people to label your data for you. And that costs a lot. Not too much, but still, again, I mean, relative to the value that you get out of it, the cost is not too much, but still it costs a lot, right? So unlabeled data set, for example, getting all the articles, getting all the sentences, right, is really easy. You just get all the Wikipedia data set and it is your data set. You don't have to worry about all the labels, right? But the moment, because on internet you have petabytes of data, right? Not terabytes, petabytes of data that you can actually scrape and you can store. But labeling all of the data, cleaning it in such a way that you have label for each of the input, that is impossible, right? So unsupervised learning is used a lot because we have a lot of data which is not labeled. So we have to make use of unsupervised machine learning models to make use of that data to get that patterns, and then later on use a small chunk of label data set to improve the model. So how many of you are aware of ChatGPT? I'm just going to give you example of ChatGPT as how they uses both of these methods in a very simple manner. By the way, the things that I'm going to tell you is not really technical. There is a lot more to it because you're new to machine learning. So I'm just going to simplify it too much for you what ChatGPT is doing. But nevertheless, let me know how many of you are aware of ChatGPT. Is there someone who's not aware of ChatGPT? It seems like no one is aware of ChatGPT. That's interesting. Really? Can you please raise your hand or just message me or something? Okay. So one. Okay. Yeah. Can you please raise your hand or something like that so that I'm aware of it? Okay. Two, four. Okay. Interesting. So it's a large language model. It's a very advanced AI model. You use it daily. Amazing. Okay. So there are people who are using it, but there are some people seems like they're not using it. That's so okay. Definitely do have a look at the Chat GPT. That is what I would say. I'm not gonna spend time in explaining the Chat GPT over here, but the point is Chat GPT is a very interesting AI tool which has completely changed the whole game. I mean, this is what we call large language models. But the way it works is it's a large language model. It is only predicting what your next word would be given the previous words that you have written, right? That's the main thing that it is doing, right? And the way it does is by the way it has learned to do that is by actually looking at the pattern that exists, right, in the language data. And particularly, it has downloaded all the petabytes of data from internet and tried to understand how language works. What is the relationship between different words by using unsupervised learning methods? Once it has done that, then it has used the supervised labels to improve their system, basically. Okay. So they make use of the combination of unsupervised and supervised learning models. And if you look at the Chat GPT 3, the GPT 3.5, it I think uses 175 billion parameters. It means to learn this pattern, to learn the language, it has to learn 175 billion different values. And that learning process is extremely costly and it uses large, very big computers. And the way it does is it's called neural networks. It's a one of the machine learning model which it uses. But I'm not going to get into the detail of that. But yeah. So did I answer your question, or um, is there anything else you have to add?
You did great. Thank you.
Okay, thanks. Okay, so if you understand all of this, right, then the whole process would become what, right? The whole process in machine learning would become, let me explain. The whole process in machine learning would become try to understand the machine learning models, right? Because machine learning model is a backbone, right? And then apply those machine learning models, right? And simply capture the patterns and so on, right? So machine learning is all about talking about machine learning models. But there is a catch. What is the catch? The catch is that we are giving data to it, right? The input X and output Y. I'm just calling it X and Y, right? Well, if there is X and Y involved, data involved, so it's not just about learning about machine learning models. You have to learn about how to, load the data, right? How to clean the data, right? How to process the data and so on. So it's all about data as well, right? You can't have just, mathematics about different machine learning models and so on. Actually, it is much more important to clean the data and have a better data pipeline than learning about too much of the mathematics of machine learning. Why? Because this mathematics is not even required. You have a library called scikit-learn, which kind of automates this whole process. It doesn't mean that you don't have to know about it. Of course, we will talk about it, but if you don't know about it in the beginning, you can still apply a machine learning model. Okay, that's second thing. And the third thing, as I said, is once you have the label, there is a learning process of a machine learning process, right? This learning process also requires a little bit of mathematics to be, that right? However, as I said, because scikit-learn kind of automates this process, you really don't have to know about that as well in the beginning, right? Later on, it's good that you know about this whole process. Okay, so basically, it all boils down to Python libraries. For example, there is a Python library called Pandas, which works with data and cleans the data and so on. I'm just wondering, so there is a raised hand by Tianhu, I guess. Is there any question or this are oh, okay. Okay, so you have a pandas library, which kind of processes your data and cleans your data and so on, right? And then you have a library called scikit-learn. Okay, this scikit-learn library is gonna deal with all of the machine learning processes. Okay, so these are the two essential libraries that you will be using. Okay, now let me actually go to the notebook and explain the whole thing a little bit more. Yes, NumPy is also being used because it's a numerical Python. It works with arrays and so on. I'm just kind of simplifying the whole process a lot over here. Okay, that's why I'm calling it pandas and scikit-learn and so on. Right. So let me share my screen and open a Google Chrome. I want you to also open a Google Chrome. Okay. Once you open it, let me know. And within a Google Chrome, I want you to open the Colab notebook. Just write Colab notebook. Once you write the Colab notebook, right, you would come to this particular location over here. Welcome to Colab notebook. Click on new notebook, and this is what you should be seeing. Okay, I will wait for a minute for all of you to open this Colab notebook. If anyone is having an issue opening it, let me know. I'll help you on that. Thanks. Okay. I'm just waiting for all of others. Those who just opens it, please send a message done or something like that so that I'm aware of what's happening. Okay. Hmm. Okay. Still waiting for others. So I'll just review what I've done. So you just have to go to Colab Notebook, click on this Colab Notebook, colab.research.google.com, right? And then you click on New Notebook. It will open a notebook for you, a new notebook for you, okay? This is basically a Python environment, and you can run Python code over here. So I can say 2 plus 2, shift plus enter. That would run the Python code for you, right? It would take a little bit of time because it is spinning up a machine. The good part about that is that this is not running on your local computer, right? It is actually running on the Google Cloud. So this Google Colab, this is running on a Linux machine somewhere in you know uh, somewhere in Google kind of a cloud, right? So so if you just have a look at the RAM and disk space over here, you would see that it gives you 12 gigabytes of RAM and 100 gigabytes of disk space, right? So this is really interesting. And if you want to upload something, you can get into the file system over here, and you can upload anything from your local computer as well. Okay. And if you want to get into the, let's say you want to understand what do you have, so you can also interact with your terminal by using this sign bang, right? Some people call it exclamation mark, whatever, you may call it bang or whatever, right? You can say ls, and that is going to give you what do you have, right? Sample data. And then you can say, whatever the, directories are. So you can say change directory sample data. Let's see. So you have you have to say, let's say, actually, you can use sample underscore data over here. Yeah, it would change the directory to sample data, right? Now, if you say list, it would give you, okay, so let me say list, change directory, then and then have a look at the backward pass. Right? The moment you go back, let me just go back over here. So if you click on this one, yeah, this is the whole place of a Linux, right? So you can get in over here. So for example, you can get into home over here. You can also get into, let's say, users, and within users, you can get into, let's say, bin, the binaries, and so on as well. It will talk about the different binaries that it contains. If you're aware of the Linux system, you would be very much aware of what is happening over here. But you don't have to know a lot about the file system over here. I'm not gonna get into the, because it's kind of a Linux. How do you work with Linux? For now, let's forget about that. Um, can you not see the sample data that I showed you in the beginning? Let me just click on runtime, click on disconnect and delete runtime. Click yes, it will create a new runtime for you. Okay. And then again, click on this folder. You should be able to see the sample underscore data. See it? Okay, awesome. Thanks. Okay. So yeah, coming back to the Python. Now, I was assuming that you already know of Python. So because you're new to Python, I'm going to show you a little bit of quick things about Python. So for example, you can do calculation with Python, 2 plus 2, 2 multiplied by 2, and so on, right? You can do divisions like 5 divided by 2, right? You can take power, for example, 2 power 4, right? You can also have, find out the remainder. So let's say 5 remainder. If we divide 5 by 2, what is the remainder? Well, the remainder is 1, right? If we, and in the same way, we can apply a for loop and so on. So let's say if I want to find out all the integer numbers, sorry, all the even numbers, so I can say for I in range of 100, right? That means that I'm going from 0 to 100. And out of all of them, I am just printing if I modulo 2 is equal to 0. That means if the number is divided by 2, and the remainder is 0, we call that an even number. So I'm just printing that I, right? So let's see what happens. So it would just print all the even numbers, right? From numbers from 0 to 100. So I can explicitly say 0 to 100, right? For all numbers between 0 to 100, it will print all the even numbers, right? Well, I can complicate this. I can say all the even numbers and all the numbers which are divisible by, let's say, 10, right? Well, that would give me, I modulo 10 should be equal to 0, right? So that would give me all the numbers which are divisible by 10 and even, right? So instead of even, let's say I want kind of a number which is divisible by 3 as well as divisible by 7, right? So that would be interesting combination. So these are the numbers, right, which are divisible by 3 and divisible by 7, right? So that is kind of giving us different kind of combination of numbers between 0 and 100. So I'm just printing them. So this is how you apply a for loop, right? What else? Well, you can apply if loop in this manner. Usually you have indentation. This indentation is very important. This empty spaces in the beginning, right? This is how Python understands that there is a block of code coming up, right? You can also say else, right? Do nothing, or you can just add a complicated code yourself as well, right? Then you can, work with, let's say, other libraries by using the import. So for example, as I said, you can simply say import scikit-learn, right? That would import the scikit-learn library, right? Now you can make use of scikit-learn library. You can import the pandas. You can make use of the pandas library. But because we are working on the Google Colab, you have already downloaded all of these libraries already. There is libraries already installed. Let's say, you know, you don't have the libraries installed. So you can simply use this bang sign and simply say pip install a library, let's say pandas. It would install a library for you, right? If it was not installed. As I said, this is a Linux command, right? So I'm just running this on command on Linux terminal, right? So you can do that. And then you can start, working with these libraries, right? So let me actually, start working with some of the code. So because what we are doing over here is looking at a simple example. So let me just show you a simple example. So what we can do is from the scikit-learn library, there is a module called datasets. And from there, I can import a function called load iris. Okay, that's a function which contains a data, right? And if I just call this function, okay, if I just call this function, that would give me the iris data, right? Now that would give me the iris data. Now iris data is about kind of a flowers, and we are kind of classifying flowers into different categories. I'll explain that. But let's say if I show you the iris data, it will be this NumPy array, right? We have 150 different samples. Okay, so there is a question. Can I ask for a copy of the recording sent to? Well, the recording would be, I think, uploaded to YouTube or something like that. In the very end, we'll explain where can you access the recording as well, probably. But yeah, so you have iris data, right? And then you can get the data from it by using .data, right? So that would give you all of the data, right? So that's 4 different features. Now, what are those features? You don't know about it, and we don't care about it. For now, you have this single sample with 4 different features having a value of what? 5.1, 3.5, 1.4, 0.2. This second sample, this second flower is having these 4 features: 4.9, 3.0, 1.4, 0.2, right? Every single feature is separated by this comma, right? So I can get the first sample. Let me show you the first sample over here, right? So this is the first sample, right? Now, if I show you the target, you can also get the iris.target. That would give you the output. So there are 3 labels, right? 0, 1, 2. So there are 3 different classes of flowers. So based on these different inputs, we have 3 different classes, right? So I can get it to the label for this first sample. This first sample belongs to class 0. Now that class 0 must be something that we don't know about as of yet, but there is some target associated with that sample, right? So you have target, you have a sample 1, and you have a target 1, right? And so on, right? So we want to use it for machine learning purposes, right? Well, that is very simple. You can just simply say x equal to iris.data, that will be the input, and y is going to be iris.target, right? That is the input and output, right? So x is input, y is output, right? And we want to learn this mapping between input and output so that we can do the prediction. Well, before we do that, what I'm going to do is I'm going to divide this data, right, into 2 sets. One of the set will be used for training, and the another set will be used for testing purposes. Right now, if you look at the total number of samples that we have for the input and output, we have 150 samples, right? Well, what I want is I want to, extract out 30 different samples, let's say, for testing so that we can find out how good our model is performing on the unseen data set. To do that, there is a function called train test split from scikit-learn. So we can say from scikit-learn dot model selection import train test split. As I said, using Python has made the whole process really easier, right? You just call that function, right, train test split, by giving X and Y as an input, right? And then what you give as an input is the test size, right? Which means how much percent of a data you want for testing. Let's say I want 20% of the data for testing, right? That would give us two things, the training data and the testing data, right? So the four kind of things over here is X underscore train, X underscore test, Y underscore train, and Y underscore test, right? So I'm getting the training input and training output, testing input and testing output, right? So if you look at the X underscore train dot shape, so instead of 150 sample, we have 120 samples, right? If you look at the X underscore test dot shape, you would see that there are 30 samples in the testing data, right? So we need this data. Why we have separated out this data? Because I don't want to give this data as an input to a machine learning model, because machine learning model is going to learn the relationship between the data, right? So I want to give this training data for it to learn the pattern, and then I'll give this testing data that I have not kind of shown it to the machine learning model. It's like what we do with the students, right? We teach students what is A, B, C, and so on, right? And then later on, we kind of test them with different kind of images that we have not shown them, right? That is how testing works, right? So that's why we have divided this data set into two sets, okay? There is more importance of this whole process as well, which is what we will explain in the bootcamp. But I mean, again, we don't have that much of time to get into the detail of that. But nevertheless, we have training data and we have testing data over here, right? So what we do? Well, you can now use machine learning model to learn the relationship. Well, what machine learning model? There can be any machine learning model. Let's say I'm using from scikit-learn, there is a machine learning model called a random forest, right? Random forest classifier, because the output is one of the label 0, 1, 2, 3. So that's a classification problem. If it was a continuous values, it would be a regression problem, right? Okay. So if you just take this random forest classifier, right, and give as an input, right? Again, you don't have to give input anything for now. Let's say you're just creating that random forest classifier. Let's say I'm calling it model. So this model is basically this random forest classifier, right? Okay. Now I said, what do? We give this training data as an input, right, to this model, this black box model, to learn the relationships, right? How do we do that? Well, the way to do that is using this simple function fit. We give the train and Y underscore train as an input, right? That would train the model. Now, if you look at the model, this has been trained, okay? And what have we given to this random forest machine learning model? The training data, right? X underscore train and Y underscore train, right? Now, if I try to predict, right? If I try to predict the testing data, what is it gonna, I'm giving the testing data as an input, right? Let me show you again what is the testing data. Well, the testing data is these values for the different samples, right? So these are 30 different samples, and these are different values that I'm giving as an input, right? What do you think it will predict for me? Anyone? What will it predict for this testing data, given that it has been trained on this training data with this output labels, Y underscore train as well? Anyone? If I just run that, what do you expect to see? Exactly, zeros or ones, exactly. So it will predict for me the labels 0, 1, 2, right? 0, 1, 2. These are the three labels. Okay, but what are the true labels? These are the predictions, right? What are the actual true labels? Y underscore test. Well, these are the true labels. You see, this model was able to predict all of the true labels correctly. So the accuracy is actually 100%, right? And it is doing it on testing data that it has not even seen. right? It has only seen the training data and its labels. It has not seen the testing data. I gave the testing data to predict the values. It was able to predict it for me. Does that make sense? And have a look at the whole process. It's just few lines of code. I just instantiate the model, call the fit function, and again directly call the predict function. I don't have to know all of the mathematics and the details and anything. It's a two-line process. So can you please ask questions as like, what is it that you're confused about in the process? Oh, so you're asking not 100%. So we have not achieved 100% of that. Yeah, you're right. So we have misclassified this one. Yeah, that could happen. So to actually find out what is the true, accuracy. So we can say predictions equal to this, right? Let's extract out this value. So we can say predictions equal to y underscore test, right? And then we can say sum all of them and divided by 30 because we have total of 30, right? So we have actually achieved 96.6% accuracy because this single sample was misclassified, right? Does that make sense? And we can then multiply it by 100 as well. So 100 multiplied by this, that would give you 96.66, accuracy. Okay. Okay. And by the way, you also have another way of looking at this evaluation as well. There is this, within scikit-learn, you don't have to even worry about all of that as well. Scikit-learn also gives you from scikit-learn.metrics, right? Import the accuracy score, and then just call this accuracy score by giving the predictions and y underscore test as an input. That would give you the accuracy, right? You don't have to do this calculation. Let's say you want to find out F1 score, which is again another kind of a way of, you know, um, uh, you know, understanding how good your model is performing. So I can also have F1 score by giving the predictions and y underscore test. So it will also give me, So, so yeah, in this case, it would not work because it's a multi-class classification. However, I can get the classification report, and then I can get the classification report, right? Let me just copy that, paste it over here, run that, run that. Okay, and let me print the result. So classification report is much more than accuracy. So it will give you the precision and recall and F1 score for each of the class 0, 1, and 2, right? And how many samples are there in each of the class 0, 1, and 2. Now, this is again, a little bit of complicated thing is how to evaluate your model, but evaluation is also very important thing in your whole process, right? But again, how you do it, I mean, it's a single function, right? So Python makes the whole process really easier, right? Over here, if I just change from random forest classifier in ensemble, there is another classifier called, I would call it the gradient boosting classifier. So instead, I can change a model like that, right? And the moment I change it here, I'll just change it here, and the rest of the process would remain same. This time I'm using the gradient boosting classifier, right? And I'm predicting the values and testing the values and see what happens. Again, I'm getting 96.6% accuracy, right? I can change the model, let's say, from, let's say, scikit-learn.ensemble. Let me change it to from scikit-learn.linear model import. There is a particular model called logistic regression, right? So logistic regression. So I can use that. And instead over here, I can say logistic regression. I can say, let's say, max iter equal to 1000, whatever, and fit the model and then do the predictions and have a look at the y test. And this is the accuracy that I'm getting, right? Make sense? So there is this one sample which I'm always kind of misclassifying this one. This seems to be, a problematic sample. You can further on analyze that as well. But nevertheless, the point is that you can also apply another kind of algorithm like MLP classifier from neural networks, right? You can apply complicated neural networks, right? So yeah, Tianhu, there is a question.
So how do I know which model we should use for this specific problem?
Well, that depends on which model gives you a better accuracy. And if all of them are giving you the same accuracy, then I would suggest use the simple model. For example, logistic regression is the simplest of all. Now, you might not know which model is simplest and what do they mean. For that, as we are saying, like, I mean, it's not possible to cover all of that in a single lecture. That is what we will be getting into the detail of, like what different models are, what intuitively they mean, what are they doing actually, and which one should you prefer, what is the whole process of selecting a model, and so on. There is a little bit of detail, but the way to apply it using Python is very simple, right? So for example, from scikit-learn dot neural network, import multi-layer uh, perceptron classifier, right? And then I can just, instead of a logistic regression, which is a simple model, I'm using a neural networks, which is one of the most complicated models, right? And I can fit it, and let's see what happens. So this time again, I'm not getting the perfect results, right? So let's again, you can change the hyperparameters of a model as well. But nevertheless, the point is the choice of model that you're making is not that simple. There are certain things involved in choosing the model that you will be using at runtime, which requires a lot of discussion and a little bit of intuitive understanding of a model as well. But the general rule is, if the models are performing similarly, you always choose the simplest of the models. Okay? So then there is a question, does one need to learn the pandas library before learning the scikit-learn, or does scikit-learn handle the data? No, you need to learn the pandas library actually. It is recommended that you learn the pandas library before you learn the scikit-learn. So the way we usually go about the whole process is, we actually teach you as a first step the SQL. SQL is structured query language which manipulates the data, which is actually very important in jobs, like um, one of the most important skill set for data scientists and so on, right? So we teach you SQL, then pandas, NumPy, SciPy, then scikit-learn and machine learning, and then there is some big data technologies that we also teach you, like Spark, like for example, how to deal with you know hundreds of millions of different data set, records, right? Samples, because it's a very huge data set. It takes a lot of time if you're using this simple scikit-learn. So Spark is kind of, using, distributed computing to handle all of those processes as well. So yeah. Okay, so are there any other questions as well? So I will be waiting for any confusions, any questions that you may have about this whole process. Adam? Okay, awesome. So, Adam, do we have, I think, yeah, so I think Adam did send a message that the recording of the session will be available on YouTube. That is there. And yeah, if you have any questions or something like that, please do refer to these surveys that has been given by the Adam, right? So let me just copy and paste that again. So yeah. So
I have another question. So how often do we need to train a custom model? How often do we can just use the out-of-box model?
how often do you need to train it, right? That's a
Yeah,
very good question. That's a
custom.
very, yeah, I understand. That's a very, very good question. Well, this is in technical terms, this has become a whole field. Previously, like, I mean, it's not that as a data scientist, as a machine learning engineer, you just train the model and then you're gone, you're done. No, it doesn't work like that. What happens is that data is continuously coming in, right? If the data is coming in, you need to update your model according to the data that is coming in. There is this term called data drift, right? Data drift means that the data set that is coming in, is having a bit of different kind of a distribution than the data that you were having previously, because the recent data captures the most recent trends in the data. So there must be a way, a pipeline to continuously update your model according to some interval, or maybe based on some kind of a metric that you're looking for. Let's say your model has started performing very bad and the performance is deteriorating. It could be after a day, it could be after a few hours, it could be after 2 days. So then you would actually go back and look at the new data and would incorporate the new data and would update your model. So the whole new model would do the prediction and would, you would analyze and look at the performance. So based on the data that is coming up again and again as a new data coming in, right, in the setting, right, you would update your model accordingly. Does that make sense? Did I answer your question, Yanhu?
Yes, thank you.
Yep. So one of the tasks, by the way, of all of you would be, hopefully, once you get into this market, one of the tasks would be to actually monitor the models, right? That's a big skill set. So your model has been deployed, your model is performing, and one of the tasks would be that you will get an email after an hour. And most of the times, every single hour, you would be like, in your daytime job, you would be just looking into how it is performing, how my model is performing, right? So it's all about looking at the metrics that you have created a script for. So there will be a little bit of visualization, a dashboard that you will look into that, okay, my model is performing, okay, this is somewhere there is a problem and so on. So you would create new features and would improve the model. So production monitoring and improving the model would be one of your key tasks. Okay? So yeah. I think Adam, you're sending a message to directly me. Instead, if you could, yeah, send it to everyone, please. Let me actually copy and paste that message to everyone. Yep. Okay. So everyone, it was nice to meet you all. If there are any questions, I will still be available. Otherwise, I hope to see you all sometime in our boot camps. And yeah, we would love to see you and have a good rest of the day. And bye-bye. Take care.